Okay, so let's start. So guys, thank you very much for joining. Again, especially Levi and Stephen, thank you very much for your time to be here. So before we actually start, I just would like to share a little bit, a very quick presentation. So if you guys don't mind. So I hope everyone can see my screen. So again, thank you very much for joining. I just want to talk you guys through a little bit about the team and basically what we are planning for the next weeks. So in terms of the agenda for today, we have the fortune to actually have Stephen and Levi here with us, that they will be discussing about advanced analytics and the automation of the APIs with Qlik Sense Enterprise. So we will kick off with Stephen, and then we will go to Levi, and then of course, if you guys have any questions, so please feel free to ask in the chat or actually ask directly to one of the speakers at the end. Before we start, I want to give a big thank you to the Qlik Integration team. In this case, a special thank you to Richard, to Ryan, and to Piers. Without them, this group wouldn't be possible, so a big thank you. And of course, we also would like to actually to share, we've been basically releasing a couple of these last months, so these meetups and also some online series in our YouTube channel with some topics. This one that we will be releasing in the next couple of weeks is actually featuring our own Ryan Arp, where he's basically sharing his experience in terms of building mashup applications. So it's going to be very interesting in terms of his sharing his experience and how we can have the integrations with Capability API with Engine API. So we'll be sharing next week and the week after some of his thoughts about this subject. And without further ado, so we have today again Stephen and Levi. Thank you very much for your time to be here and to make this presentation. And yeah, the stage is all yours. So Stephen, when you are ready, feel free to start. Let me stop and give you the permissions to share. Yeah, you can already share.
That's great. Well, thank you, and hopefully you can hear me well enough. And my internet connection doesn't come down. I'm joining you from my vacation away, so I'm just got back from the beach and now going to talk to you about Qlik and the Advanced Analytics Integration and some of the work we're doing in this area. So I shall share my screen and we will get going. So, okay. All right, so this is a session that that in part did at Qlik World this year. If you've not had the opportunity to see some of the sessions from Qlik World, then you know, there's a whole wide range of them, and this was one of them that was pre-recorded for that that session. Obviously, all of those are available online if you're not still cruising through all of the backlog of those sessions that were available. So I'm Stephen Pressland. I'm a senior product manager at Qlik. I look after augmented intelligence, so all of our augmented analytics capabilities, and you know, that's everything from our conversational analytics with our chat interfaces through to our insight advisor, insight generation capabilities that are in Qlik, and a whole raft of new capabilities that we're bringing in that area. And later on, if we get time, we'll show you some of the advanced analytics capabilities that that we're adding to Qlik as a little sneak preview. But let's kick off and talk about this topic today, which is advanced analytics integration. So this is server-side extensions and really understanding how we can utilize those and frame those correctly in terms of how they can help you with Qlik. So I'll jump past the legal disclaimer, which says that everything I'm about to tell you is a lie. And we'll jump to the agenda. So we're going to really talk about, what are analytic connectors, how we can use these, typically with R and Python, but really look beyond that in terms of this being a framework that can work with a lot of programming languages and can have a really wide range of applications. It's not all about advanced analytics when it comes to server-side extensions, and it can, you can do a lot with those. There are a number of integrations, ones that have been built. So I've built some, which we'll talk about, with commercial platforms. It's very much, we look at R and Python typically as examples of where people are doing machine learning. More and more organizations are looking to commercial platforms, whether they be from big cloud vendors or from very specialist organizations. And in many cases, there's a much better cost benefit analysis when it comes to doing that. So we'll look at some of those commercial platforms. And then we'll talk about how these can be deployed across different flavors of Qlik Sense. So let's start off. What is an analytic connector? So as I've mentioned, analytic connectors go by a few different names. So server-side extensions is kind of the technical API level name. Advanced Analytics Integration, really more of the marketing name. And of course, if you're in the QMC on a Qlik Sense server, it's going to be analytic connectors in the QMC where you can configure these. And fundamentally, they are a mechanism for offloading calculations from the Qlik associative engine in real time. And they can be used in the load script or in a chart expression to provide a really unique way of being able to integrate with Qlik. Now, I'm not going to say that we have finished the story on server-side extensions. They are a little bit of the wild west of Qlik when it comes to integrating with them. But those that have utilized them and sort of persevered through that, have been able to achieve some great things. We also have a big emphasis on server-side extensions moving forward, and from my point of view, this isn't sort of a dead technology. This is very much one that we will be investing in moving forwards. As with everything in an organization like Qlik, it's just a case of priorities and timing to get that done. So this is what we're talking about when we refer to an analytic connector. So how do analytic connectors work? They're kind of a little bit backwards in terms of it's the opposite way around to the way you would potentially think about these. You essentially are creating a server which the Qlik associative engine on your Qlik server is a client of that service. And so we are utilizing a protocol called gRPC. It's a Google developed protocol for very fast and efficient binary transfer of data over HTTP2 protocol. So everything we're talking about is standards on top of standards. So gRPC is open source standard. It sits on top of HTTP2, which is an open standard, be it used not quite as much as the more traditional HTTP1, but gives us a lot of benefits and capabilities. And one of the main things here, and I often get the question, why do you look at this rather than doing something with just a REST endpoint or connecting to REST endpoints? And it's really about speed, data transfer, and efficiency. gRPC was designed by Google in order to provide a very fast binary throughput between two systems on a network, and that's what we're doing here. And we're maintaining sessions, so all of the load balancing has to be done at messaging level on a much higher quality load balancer than you would normally have just as a standard HTTP request load balancer. So paired with the right technology and the right architecture, you can really make gRPC do some fantastic heavy lifting for you. So here, whenever we're requesting anything from the Qlik engine in the client or anywhere that we're attaching to Qlik Sense, the associative engine is then making calls in real time, sending data to the plugin, and we'll see how that works in a moment. So let's take a look at how this works if we're using R and Python. So if we think about what Qlik does in terms of the wide range of use cases, Qlik Sense will extend very heavily into statistics and algorithms and the advanced calculations. And I always say, if you can do it in the engine, do it in the engine. You know, there's no point reinventing something that's in there, and there's some really advanced capabilities, and many people don't appreciate or know the capabilities that are available. It's always worth having a read through the help site and really looking at some of those functions that are available, or the prefixes and the keywords that can be included in Qlik script, because there's some really advanced stuff there. But there gets a point where we need to extend beyond that. And so once we've delivered those native capabilities, that's where server-side extensions can give you, scenario analysis, mining modeling, some advanced statistics algorithms that aren't available in the engine. And so, I would say there's two reasons why you would do this. One, because you're working with something that's very proprietary. So Qlik would never implement that because it's very proprietary either to your industry or to your organization. Or you're working at the cutting edge, that even if Qlik did implement something, it would probably already be out of date by the time you were trying to implement there. So where Qlik has to think about all of the customer base and priorities across all of the different customer scenarios and use cases that we have, customers don't need to worry about. They just have to worry about themselves, and this is where server-side extensions can provide that framework for you. So how does it work? If you're interacting with Qlik in any way in a chart with a chart expression, so you're operating with a hypercube, and for an organized a meetup that's talk about API integration, one of the really important things here is that because this is all in the engine, this doesn't rely on the client to do anything. This doesn't rely on you having JavaScript code inside of a Qlik chart. This is all directly at the engine level. So if you're making an engine call through any process, through any mechanism, through any intermediary that you're choosing, if you're generating hypercubes, you can use this capability. And so when you're interacting, typically, normally we would interact, that request would go to calculate with the associative engine. That would then return back to the client. But what we're going to do now is, rather than return those calculated hypercubes back, we're going to send those to a third-party plugin in terms of the script or the function definition and the data. And we can send this to any connector that we've built that supports that gRPC protocol. Then the external engine will run, it will calculate those results, it will return them to the Qlik associative engine, where it's then combined with the new data, and the results are returned. So now, by the time this gets back to whatever client it is, whether it's the Qlik client or a custom client that's using the APIs, it's just data in a hypercube on a data page. So you don't need to do anything special other than just render that however you choose. And that round trip happens every time you're making a selection, changing context, searching, anything that will cause a hypercube refresh. Now, that's great for some scenarios, and we'll come on to the pros and cons of these in a second. But there is another mechanism which is about integrating into the data load. And for many use cases, this is preferable. If we're loading source data into our Qlik script, that gets loaded as a table in memory. At this point, we can send a whole table of data, any subset of that table, any element of that, to a third-party connector. Those results can then return back a separate table. So it's table of any shape and size in, and a table back of any shape and size. And importantly, because of the power of association, we can perhaps just bring back, a row ID, and so just bring back a key and bring back a set of columns for a prediction. And so table in, table out, associate the results. You haven't got to send data on a round trip. You've not got to replace it. Many of those traditional data science type activities where you've just got to replace data, you can build it in, keep them as separate tables, join them later on if you want. It's all in line of the Qlik script. And by the time that data gets back to the engine, it's just data like any other data that's been loaded from a source. So this becomes very powerful to do at load time, where you've not got the pressures of time constraints, etc. And also, if a prediction, for example, is done at a transactional level within data, you're not going to be in a position where you need to do it over and over again every time someone makes a selection and get the same result. There's no point computing something that doesn't change. So in terms of the options for these, you've got the Qlik data load, batch processes. They can run for longer. They're not impacted by the selections of the user. It's one process for all users of the application at reload. There's obviously a lot of efficiencies that come there. Chart expressions, on the other hand, real-time processing. They need to return results quickly. The user experience in Qlik is that you get instantaneous results. If you're slowing that down and you're doing it outside of a context where the user understands that trade-off of a slowdown, it's going to just feel like it's a bad Qlik experience. So using them in the right way with the right outcomes. Obviously, importantly, they're impacted by the user selection of the parameters. So that really influences the outcomes of that data. And then each individual user, importantly, gets their own results based upon their own inputs. So if you've got variables, you've got selections, every user gets a custom result set, which is a very powerful experience for you. And so all of this is underpinned by the choice of ML calculation platform. Because it's an extension that you can build or you can buy from a partner, when these are being used, they are against the system of your choice. Qlik's not telling you you've got to use one solution or another. So let's take a look at some of the sort of the deeper level of this, and we'll talk about the different function types. Now, I'm using the script functions here, and they are really the most powerful. And even if you're not actually going to have script inside the script component, these are the most flexible because of the way in which you can bring multiple parameters. But there are different types. If you do create functions in a server-side extension, the same principles apply. We can do an aggregation function. Here, we are sending the data before the hypercube is aggregated. It will have n row input and 1 row output. And that's an important thing to understand. One, because if you've got a lot of data, you're going to be doing a lot of heavy lifting in the extension. Not always a good choice. And also, if you have all the dimension values or combinations of dimension values where there's multiple dimensions, you will be sending a request for every subset of those. So here, a KPI is 1 request. A bar chart with 8 dimension values is going to be 8 requests. that does slow down. That's not something that you want to be doing at any significant volume of data. Just the overhead of that processing is significant. So aggregations are rarely used, but they do have their place in some examples. More commonly is the scalar or the tensor function. Now, the reality is that most of these are actually scalars. Certainly when we're doing them in a chart expression, they only really become a tensor when we're in a load script at the moment. But here we are sending after the hypercube has been aggregated, and we're doing it n rows in and n rows out. So here a KPI will be a single request, but a bar chart will also be a single request, and all of the rows of data, the 8 rows of data, will be sent across, and you'll be expected to send 8 results back that you will then put alongside. Now, this does make things like forecasting a little tricky, because you have to send the placeholders for the data to be sent back in. So it requires some trick with either placeholder data or with set analysis. So forecasting this makes it a little bit tricky, but the principle here, n rows in, n rows back, post aggregation, this is the workhorse of a server-side extension. So if we see an example of this on a load script, if we've just loaded some data, standard data from a resident table, this example here, we are using a different syntax that's included with the load statement. And here we have load extension. So now we are specifying that we want to send this table. So here, the rentals table, and I've actually selected specific columns from it. And they are being sent to the connector. The results are being sent back, and I'm sending back row ID and P, but I'm actually putting a Qlik function around that P, because by the time it gets back, you can treat it like any other load statement. It's exactly the same principle. And so that round trip of data just means that you get that end-to-end data loaded. So it's sending the rentals table, and it's returning back the row ID and P, which is coming back, and I'm renaming it as prob score. And then I've got 2 tables in my data. So let's take an example of some of these in action and see this going. So here I've got an application running on my Qlik server. So let's just, where's this? And in this particular example, I have a set of data which is crimes that are reported on a month-by-month basis, and I'm just showing these with the grey line. Really simple, straightforward. The blue line, the blue dotted line here, so this is built with one of our new Picasso-based nebula charts in Qlik Sense. It is using the this is a Holt-Winters forecast that's taking place in R. And we can see that across the historic data, it tracks pretty well. So it's a pretty decent time series decomposition and forecast. And now I'm asking it to forecast for 48 months into the future. Now, if I change this and say, actually, I want 45, these results just change instantly. Everything just updates and refreshes. And this is running a little slow. Normally it's really, really quick. So this now is updating and refreshing for us. But that's with all the data. Perhaps I'm interested in selecting a few different police forces. Now I've got a completely separate forecast that's been calculated just for me in this particular case. Maybe I'm interested in understanding different types of crime. I can now see those and explore that data. All of this calculation, the forecasting, being done in real time using the server-side extension. Now let's take this off and look at another example here. So this is a good example of time series decomposition. And in this particular case, I've got this time series, which is showing me my antisocial crime over time. And I can probably just about get a gist of there being a downward trend. But actually, if I do decomposition and break this out, I can see very clearly that there is a downward trend on that data. There's also a very high amount of seasonality in this as well, which is quite interesting because here I can see there's a plus and minus 40 swing, and we can see there's more antisocial behavior in the summer months, less in the winter months. So we could probably have got a gist that there was some seasonality from this top line, but this becomes really great at showing us how these break down. And then we have the random component, the stuff that's left over. And we see some of that in this data set. Now, if we were to compare that to, say, drug-related crime, this is where actually this becomes very helpful. It's a good example of where this can become very helpful, that if I was just to look at that top line in the data, it wouldn't really tell me a lot because there isn't very much information. But I can see that there is a trend where there is a trend over time. And importantly, I can see there is some seasonality to drug-related crime, be it it's on a much smaller scale. We've got a plus 1.8K to a minus 1.2K over the course of the 12 months. And that really brings us to home to where we can see the nuances of our data by applying these methods by using a server-side extension. And then finally, an example of where we can use this to provide clustering. And this is really great because we've been able to show here using k-means clustering, using Qlik Sense with a server-side extension. But this is actually a really good opportunity to say, the next time that I'm showing this, we won't actually need to use a server-side extension for this because just to give you a glimpse into what's coming in September on all Qlik platforms, we will be providing k-means clustering directly in the associative engine. So this talks to some of the new capabilities that we're adding, which not just relying on everything to use server-side extensions, but still investing in building out more advanced capabilities into the engine and doing more of that over time. So in September, k-means clustering like we have here won't require a server-side extension. We'll be able to do this directly in the Qlik application using that on Windows, on cloud, and across all of your applications. So that's some good examples of how we can use this to bring this together. What I will do is just show you again, because it's the power of using server-side extensions in the engine, we don't require to build special treatment of those calculations. And so in this particular case, I'm using alternate states with this, so I can then say, okay, right, let's compare antisocial behavior between Avon and Somerset and Bedfordshire. And now we can do a comparison and look at the overall the forecast. We can look at a decomposition of those two. We can look at the relative performance. If we do a decomposition, we can look at the trend. We can look at the seasonality, and we can see actually, that they follow on a fairly similar seasonal pattern, be it there's a different magnitude of the number of crimes that are taking place. And some have had slightly different ebbs and flows in terms of the amount of antisocial behavior. But again, all of the power of Qlik, all of the capabilities that you can use through the APIs delivered with these engine extensions when you're using them. So let's jump back in here and we'll carry on. So let's just talk about some of the commercial platform integration. So many customers, as I mentioned earlier, don't want to just use open source. They've got a commercial relationship with a partner. They've got a commercial platform that they want to leverage, and they want to bring Qlik and that platform together. The data science platforms are only so good if you don't get the results of them out to users, get people making business decisions based upon that output. Now, for some, it will just be export data, load it into Qlik, job done. And that is a perfect solution if it's the right one for you. But if you need something a bit deeper integrated, then server-side extensions can provide that platform. Particularly if you're doing a lot of your data prep in Qlik, you don't want to have to do your data prep, export the data, send it to be scored for predictions, brought back into Qlik. You want to have that round trip nice and seamless inside there with the load script in Qlik. A good example of how to use it. Now here we've got Qlik and DataRobot as an example. Here we're sending data in from Qlik Sense through the associative engine, we're sending it to DataRobot. We're then sending those results back where we're scoring data against, we're building models. We can then send those, create those models, and we can then use those to score in the future using a server-side extension. And so in this particular case, this is a Qlik to DataRobot extension, which I built. It's open source. Anybody can take it and do what they like with it. But this just essentially acts as a bridge between Qlik and the REST endpoints of the APIs of DataRobot. So let's look at a very quick example of that in action. And what I wanted to show with this is the fact that this is a good example of where we can use the real-time example to explore this in the data. So here we've got two different scenarios. So we've got two alternate states. And in this particular case, I'm looking at customers that have churned with us. So customers that are taking out mortgages and whether or not they're going to leave us. And we've built a predictive model to understand that behavior. And then in this case, I'm then saying, okay, if I change their interest rate, how many of these people are likely to churn? So if I decrease their interest rate by 0.9%, then actually less people, as we'd expect, will churn and go to another lender. In this particular case, I just want to point out what's happening. Every time I make a change, that is sending 100,000 rows of data to the Qlik extension, which is then being packaged up and sent via a REST endpoint to be predicted. Those predictions are being sent back. They're being sent back into Qlik, and they're being loaded then into into the engine and rendered, not in one case, but we've actually got 3 different visualizations here because that function is happening within an aggr function. So we've got 10,000 rows inside an aggr function, which is then being re-aggregated multiple times on our sheet every time I make a change. And that's happening in a second. And so even with that transfer to a REST endpoint, it's still really fast and can work at great scale. And we've got all the full power to say, okay, right, well, let's compare all of our customers with a loan of 7 years to greater than 7 years. And now we've got 2 different cohorts where we can explore, okay, actually those customers that have been with us for a long time, we could increase their interest rate and they're probably still not going to massively leave us. So we can explore this, understand those scenarios, and we're doing this with a machine learning platform which you can buy off the shelf, doesn't require any coding, maybe the right one for different customers. And then also integrating with Qlik through an off-the-shelf open source connector. So nothing to write, but utilizing that capability. So shows you, the full spectrum of you being able to build something yourself, do it off the shelf, but ultimately getting some really great results when you build this into a Qlik application without any particular complex processing required. But as I mentioned when we're talking about the agenda, it's not just all about advanced analytics. We've talked specifically around machine learning. This is a great use for it, but actually there are other uses for analytic connectors. So if you're using cloud editions of Qlik Sense, which I'm sure many of you are beginning to start that journey of using Qlik Sense Enterprise on SaaS, we have GeoOperations. This is a full range of geoanalytic calculation capabilities, some of which can be done in real time in chart expressions using a Qlik first-party analytic connector. Other examples that I've either seen prototyped, I've built myself, or other people have used in production examples: audit logging, commentary saving, translation, integration with APIs if you want to bypass things like cause issues, encryption of data, data obfuscation, many different additional uses, because ultimately data in, data out, any form of data processing you can really do with this. So in terms of deployment options, on Windows, in Qlik Sense Enterprise, you just create the analytic connector in the QMC. You don't need to reset the engine. You just add it, and it's going to be included. Qlik Sense Desktop, you just add it to the setting INI file. It's just a single line to add in there. In Qlik View, again, exactly the same setting INI as Qlik Sense Desktop. Add that in, and that fully will work in exactly the same way. If you're using Qlik Sense on Kubernetes, we can define these in the Helm YAML file, and there we can specify analytic connectors. So got a couple of minutes left, so just a few final thoughts on how this works and what you do. So in terms of performance optimization, play around with the way in which you process results. So if you're using different functions and you need to split those out, you can actually concatenate calls together, pass them within Qlik. Use aggra functions to reuse the same request multiple times with post aggregation, so that you're using the same output. Use calculation conditions and variables to control when they should be executed. If you're going to have something that only works with so much data, restrict it to only work with so much data. Yeah, all the standard Qlik Hypercube capabilities work there. Potentially use multiple SSEs to avoid bottlenecks. You can get some really fast throughput, particularly if you're not using Python. Python is not great at gRPC, so you will get a slowdown with Python, but other languages, any compiled language, you can get some really high throughput with the connectors without even needing to go to load balancers. But if you've got multiple SSEs, you duplicate the amount of traffic that can be processed. And remember, Qlik can only be as fast as the external engine, so optimize those functions, make sure that you're using the right use cases in the right place. Try not to use if statements. It's fine if the if statement's outside an aggra function, but don't use if statements within the initial call, as they aren't cached, and that will just again just remove some of the optimization that server-side extensions get with engine caching. Use a table load. It is possible, I didn't even show you how, it is possible to load data row by row in the load script. Don't do it. It's just not worth it. It's extremely slow because every row is a separate call. Just do a single call for the whole table. All of the normal Qlik performance mechanisms apply there. So a few known limitations to be aware of. So data is sent from Qlik in the order that it's stored in the Hypercube, or the order it gets returned, not how it's sorted in the visualization. You need to code against the fact that you don't know what order the rows are going to come over in, and you need to make sure that they are returned in that same order. So it just means you need to just do a little bit of boilerplate code around the data to make sure that the data as it goes into the server-side extension is exactly the same order as it comes out. You'll probably need to do some resorting depending on the types of use cases. Something like data scoring doesn't really make any difference, but other use cases, you need to just make sure the sorting is there. You can use some agri-sort functions to get the data through, but again, it's always just make sure that you know exactly what order the data is coming in and don't rely on it to be sorted. Custom functions require a static number of arguments. So if you need more, you can either achieve that through concatenation or use the script functions. Script functions are usually the best way to go. And again, if you're using a function, there aren't any static arguments. Use a script or fetch them and then ignore them, but they'll be sent every row in the data. And importantly, the cardinality must match the chart calculations. So you need to use those placeholders for things like forecasting. If you want to follow up on any of this, Qlik Community, there's a server-side extension section where there's content that you can download. And on Qlik's open source software on GitHub, there are two repositories, which the main one is around server-side extensions, and then there is an R plugin one specifically. And also, if you do reach out to me, if you want to get really serious with R, I have a high performance R connector, which I've built myself, forked, which is available. It's like a Docker container, etc. So that's it from me. We're at time and 1 minute over, so I shall wrap up now. But this presentations, again, if you want to watch any of this content, is available from the Qlik World sessions. If you've got any questions, do reach out, stephen.pressland@qlik.com, and I'm on branch Slack, Qlik Stephen Pressland. So do reach out if you want to follow up. There is a channel, SSE, on branch Slack, and again, that's something that I monitor and keep an eye on. If you've got any questions, any requests for functionality, do raise them on the ideation board, and we will be able to help you get those prioritized accordingly. But use the ideas board on community in the first instance to get that feedback. Okay, well, I'll stop there and stop sharing. And obviously I'll give the opportunity if anybody's got any questions now before we hand over to Levi. I'm more than happy to answer those.
First of all, really good, actually really good presentation. Thank you very much. Just to clarify, the URL that you share in the Qlik community, and it's already answered. Okay, so so we can download basically these demo applications and also the plugins in those URLs that you just shared.
So the specific demos that I showed aren't there, but there are a bunch of demo applications in the GitHub repositories that show you how to get started and how to use the content, and that's there. So I've now just seen, because I was sharing my screen, I've now just seen the chat with the questions in. So let me just answer some of those. So so someone was asking around what does ML stand for? So in that context, it's machine learning. So that's the acronym there that we're using. So any data science machine learning platform, to be honest, any piece of software that's doing a calculation doesn't have to be machine learning. It can be any other proprietary platform that's doing calculation. You've got that choice of that so that you can use. Cool. All right.
Stephen, again, thank you very much. Thank you very much, guys. Is there any other questions you want to answer before we move to Levi?
Yeah, I got one question for Stephen.
Yeah, go ahead.
Yeah. So in DataRobot, the open source models are available. I mean, can we use the already available models? That means, for example, for any prediction, is there any ready model is available there?
So in DataRobot, that's a complete platform that builds the models for you. I don't think you can import models to DataRobot, but that you'd have to pick that up with them as with any of the other sort of third parties involved. But if you've got a particular model, building out an endpoint, if you've got an endpoint, you can very easily plug that into with a server-side extension into Qlik in any language of your choice. Qlik's got examples of this running on all the major languages. Some of the best ones are the C-based ones. C#'s my favorite. Works really well. Go works really well, really fast. Python not so fast, but depending on your use case, it might be good enough. You just have to be mindful that Python's not a very strong, high throughput, multi-threaded, multi-request language. It's very much used for single operations, but Python in the right circumstances can work. And obviously, if you've built machine learning models in there, then it's good. But I know a lot of people, they might build a model in Go or in TensorFlow and deploy it in Go. After having built it in Python, and you get some really fast throughput on gRPC there.
Great, thank you.
Okay, cool. Stephen,
Cool.
again, thank you very much. And also, thank you for the tip in terms of September, what we will get in September. We will not share, don't worry.
It's a little sneak peek, and
no, really good.
Yeah, we'll work that out, and you'll see that come up with the September release. Cool. I will have to drop off, so just email me if there's any other questions or anything. But I know you're going to be in great hands with Levi and his session, because you'll have forgotten everything that I've talked about once Levi gets started and talks about all that fun stuff with automation and the APIs. So I will leave you to it, and thank you very much, everybody, and enjoy the rest of the session today.
Thank you, Stephen. Thank you for having the time to be here. Thank you very much. Right. Take care.
Bye.
Levi? Yep.
Thank you much. Let's share my screen.
Yep.
Okay.
Cool.
So we're going to cover what I've classified as just automation APIs inside of Qlik Sense Enterprise, right? So this is the repository API and the Proxy API. Think of them as basically back-end APIs for the product. For those who don't have background here, right? REST APIs, they're representational state transfers. They're fundamentally stateless, as opposed to, let's say, the Engine API, which is fundamentally stateful. If you make a selection, the available green, white, gray is there. Whereas, if you get a list of apps, it doesn't matter what you've done before. The list of apps is the list of apps. You're always going to get that. They do share, common HTTP verbs. Get, post, put, delete. Those are the most common ones, and they have a relatively uniform interface inside of our product. There are some quirks around the edges, but fundamentally, if you want to get a list of apps, you can call. If you want to get a list of apps, you call QRS app. You want a list of users, QRS user, et cetera, et cetera. It's relatively straightforward. So just to orient ourselves, right? We're talking about, and this is, I don't know how much you guys see these marketing screens, but this is a common slide about the platform APIs that are available inside of the Windows platform, and we're just highlighting what we're talking about here, right? We're talking about the RESTful APIs, so the proxy for authentication, session management, the repository for backend management, scheduling of tasks, administration. And a call out here, and I'll show it later. But especially with the repository API, I mean, this is all very clearly exposed in the browser's dev tools when interacting with the product. It'll show you what it's doing, right? So if you have a question about how to do a certain type of thing, the browser dev tools are your best friend there. So why would you use these, right? So for the repository API, you're basically managing asset and metadata. And I use the word metadata there very intentionally because you can get a list of apps. Your site has 1 to 1,000 apps. Now the repository API does give a listing of sheets, but that's about as deep of a grain as you're going to get. You're not actually reaching in and seeing the expressions used, what visualizations are present. It's all about metadata of an application or an entire estate. It's commonly also used for coordinating reloads. For example, if you wanted to integrate Qlik into an enterprise scheduling tool, you'll likely use the repository API to interact with the task. So you'll put that in Control M or whatever tool you're using. Another very common use case is to push entitlements from some other system, right? So maybe you're not connected to Active Directory or an LDAP, so you can't get entitlement information, group metadata, and you want to find a way to programmatically push that from some source system. And the repository API is perfect for that. For the Proxy API, it's primarily and almost exclusively amongst our customers used for creating sessions, and I'll sort of go into that in a bit more detail. But when you create a virtual proxy, there's a method of authentication, and one of those is listed as ticketing. This is the default, right? You go in and you use your Windows credentials. Technically, under the hood, it's actually doing web ticketing as well, and you can simulate that. One use case that I found very helpful here with the Proxy API is emulating users, right? Let's say we've got a pure Windows authentication environment. I can emulate any arbitrary user if I have access to the underlying certificates to trust the exchange. So if I wanted to preview, let's say, security rules, or an end user experienced a problem, or I just wanted to make sure that things look good for upper executive, I could emulate their identity in a relatively easy manner. So in terms of connecting to these APIs, we have basically two options, right? We can go over the proxy. So we're going over the configured HTTP or HTTPS port. We're using the authentication that's configured there, right? So certain ones of these are going to be easier to emulate than others. Header, JOT, those are relatively easy to emulate no matter your programming language. Windows NTLM can be done using some tools. For example, Windows PowerShell obviously is a bit stronger at it than, let's say, Node.js. But it's really up to the support of that library and to the programming language of whether it can do that. Authentication mechanisms like SAML generally don't work, right? You have to go to a web page, enter some credentials into a form. You can, of course, automate that with like Selenium and spin up a Chromium browser to emulate that process, but that's usually a bit heavy. The one sort of thing to consider here, right, is it uses a quote-unquote session, right? So inside of Qlik, we do limit the number of sessions, concurrent sessions that a user can have, and that limit is 5 in every 5 minutes. So if you just repeatedly make requests over the proxy service as a user, you will quote-unquote use up your session allotment. So you need to have integrations that use the proxy service, either use dedicated service accounts or be relatively low throughput. The other method, and generally the more common method for most automation purposes, is going directly to the repository service. So we're not even going through the proxy. We're going over directly to the repository on its API port. We're using the internal certificates for authentication, and we're doing authorization based on our required header. Now this is using an internal port, which may not be exposed externally. So typically this is done behind the firewall, server side. And this sort of blends in over to the use cases of these two different types of approaches. With the proxy service, fundamentally you're using an untrusted system, right? The user has to provide some identity to be able to go through, and then you programmatically access it. This is what would happen if inside of extension you were calling a repository API endpoint. Is you're likely hijacking the session the user has with Qlik. So your extension doesn't have any real understanding of who the user is, what they can see. It's just hijacking what is already there. As opposed to going directly to the repository service, that's got to be trusted systems, right? Because you can easily arbitrarily adjust the header, emulate any user, and Bob's your uncle, and now you're basically running as root and can do whatever you want. But this is ideally suited for back-end systems, trusted systems, automation that's occurring programmatically from servers. You don't need to worry about authentication, whether someone's credentials change. You want them to be, you're defining who the user identity is, and you're doing it for a very intentional purpose, and therefore it's perfectly fine to go directly to the repository. The general request structure, right, is that we've got authentication stuff, right? We're defining who the user is, and we're somehow authenticating, whether it's a certificate, whether it's jot header, who cares? We've got a verb, right? So we're describing what we're trying to do. We've got an endpoint with some potential parameters. We see the only required one here, which is XRF key, which is Qlik's albeit minor attempt at ensuring requests haven't been tampered with. You need to have a 16-character alphanumeric value that's listed in the endpoint as a param, as well as in the headers. We've got a content type specifically for put and post, right? We need to define what type of content we're sending over. And we've got an XRF key, or Qlik XRF key. Again, it matches the URL param on top of that. And then if we're using certificates, we're defining the user using the syntax Qlik user. User directory equals whatever, and user ID equals whatever. I've intentionally chosen SA underscore API there. That's an internal count that is shipped with the product, which is strongly encouraged for your API integrations. A lot of folks tend to use SA repository, which is a user account which, strictly speaking, does other things. SA API is there purely for you to use inside of API integrations. So from a logging perspective, you can see that this is your integration as opposed to an internal process. In instances where this matters, right, I've been involved in situations where customers' integration points have deleted content. And if you're running it as an internal account, it's not necessarily obvious who is doing that. There are certain ways to track that eventually, but it's ideal to use dedicated accounts for this. So from Audiny perspective, you can get a sense of what you've done, who's done it, and ultimately you can trace back to why. And then with put and post, we need to send some sort of body. With posts, we need to match the spec of what we're sending. With puts, we're typically adjusting things, right? So we need to get some stuff from Qlik, make an adjustment, and then send it back. Again, this is 90% true, is that there's consistency across the entities, right? So an entity is just a thing, whether it's an app, a user, a tag, a stream, a task. They're generally the same. Get, you're retrieving something. Post, you're creating something. Put, you're updating something, but you're updating a specific thing. You see the ID at the end. And then delete, again, we're removing that specific something. And the usual flow from an automation standpoint is that you get with a filter, you're saying, I want to get all apps whose name equals operations monitor. We then get the app ID, and then we can get the QRS app ID value. So we can get the full entity for that specified ID using some meaningful qualifier, like an app name, and then maybe we do a modification of the name or the stream, let's say, or the owner, and then we put that back in there. So the flow is, this sort of flow is relatively common. And these are some helper APIs before we jump into actually walking through some examples. These are some helper APIs that are critical to know if you're interacting with the repository or the proxy. The first one just generates the full spec of the repository. So if you wanted to know, a reload task has a status of 3. What does 3 mean, right? What is the semantic value of 3? You've got the enums defined there. You've got all the status mappings of things. It is an extremely powerful endpoint. It's also rather large in many respects, right? So this is typically done when building things out as opposed to as a part of a regular course of business. We can define relationships using QRS about API relations, so we can see what is related to what. So for instance, an inspection to this endpoint would show us why when you're building out security rules, there's no way to limit a user's access to a trigger based on their access to a task, because fundamentally triggers aren't, they can be used by task, but they're not related in a hierarchical relationship to task, right? A sheet is inside of an app. A trigger is used by a task, but is not wholly under it. There's no parent-child relationship there. So from a security rules standpoint, you can't use that inheritance. And this endpoint would show you what type of inheritances are there, right? So an app exists potentially inside of a stream. You can inherit from a stream to an app. The next one is a listing of all the repository endpoints. So you can get a listing of everything that's available. So if you're curious about, I need to do some auditing, you can pull that and relatively quickly figure out what kind of endpoints there are for auditing purposes. Maybe you then consult the help docs on specific endpoints that look curious. But this is extremely helpful when you don't know quite what you're after, or you've got a general clue about what you're after, and you don't want to necessarily scan through mounds of help docs. You just do a Control F or Command F through a listing of 1,000 or so endpoints and pretty quickly find the answer. The next one there, right, is we're getting a blank example of a structure. So if you're trying to create something, an app, a tag, a custom property, you can get one that already exists and just copy off of that, or you can call this endpoint and get a blank example of what the actual JSON structure of what this thing would look like. So you can programmatically fill those values in and then create it. The same is true, by the way, for the proxy service. It can also tell you all of its available endpoints. That's relatively limited. We're really just creating sessions, getting sessions, but if you want to explore, it's there. So let's go over just quickly a couple of examples of using this, right? So I've got examples going on a dummy system in Python, JavaScript, and PowerShell. I personally am far more comfortable with PowerShell. It's so easy I can figure it out. But as you can see, just sort of scanning over the Python example, right? It's relatively intuitive, even to a person who's doesn't really know Python, what's going on, right? We're defining a variable. We've got some header values, which is used in the request. We're using a certificate. We're defining the URL and passing that variable up here, and then we're doing a get with all of these values. And so doing something like this, we can go Python QRS about, and now we've got a list of the applications that are on the system. We have 3 apps on the system, but this could be adapted to any sort of integration point. And let's just go to scripts, Node.js. Same principle here. We're defining some params, host, port, endpoint, method, some header values. We're reading a file, so we need a library to interact with the file system, and we're just doing a HTTP get. Nothing too complicated here. This is quite possibly the most basic example. Node QRS, and now we're figuring out what version is going on here, and I'll post these up as examples. But again, these are intended to be extremely basic to show the minimum viable candidates. You'll likely, if you're doing automation, want to integrate this into a bigger workflow. This is just but one piece. And to that end, something I did want to sort of go over is a couple of lesser known but still powerful API endpoints. So there are 2 ones I want to specifically call out. These are the ones that are generally considered the sexiest when you're trying to build out integration points. The first one is going to be a notification. So you can subscribe to change events or to creation events inside of Qlik, and Qlik can send you a post once that has occurred. So the use case here is do something when something changes, right? So if you wanted to say if an app is published to a stream, tag it with a custom property. or export it and put it to another environment, which is this project here that my colleague worked on my team, which is basically listening for applications as they change, and if they meet some criteria, it's automatically exporting it and importing it into a second system. So this is promotion across tiers, but event-based, right? So traditional method for doing this style of work would be in batch. You schedule it at night. It would get all the things that have changed, export them all, and then import them all to this next system. This environment or this approach using the notification endpoint is listening to change events and then it's doing them immediately after that event happens. So let's go ahead and I'll include an example of, I'll export a copy of this Postman project, which has all of these examples here. But creating a notification is relatively straightforward, right? We're just hitting the notification endpoint. We're saying that we're interested in users, and we're interested in change type of 1, which happens to mean creation. We get a handle back. Strictly speaking, this handle doesn't matter all too much. If you create this 50 times, you'll get back the same 50 handles. So practically for an automation standpoint, you can create this intermittently if you don't want to necessarily create a Windows service that is connected to the repository service. So you can ensure that this exists post refresh of services, because these notifications are ephemeral. They're not persistent anywhere. Restart services, they go away. The cleanup mechanism happens on service restart, so you need to ensure if you're using this in production, you're constantly creating that handle or that notification so that your listener can be notified. So we're sending a body of just telling it where to send posts to. In this example, we're running a local server on this port with this route. Let's go ahead and create it again, and let's go ahead and open up a JSON server. I'm using Flask here, but it's, again, nothing too crazy. It's just listening. It's not actually doing anything. And let's go ahead and this over here is using PowerShell, and we're connecting, and we've created a user. Created a user with that ID, and that's been processed. And if the demo gods are correct, then we will get an answer here. And let's go ahead and delete that, clean up. So we're creating a user, and we're just creating a random user, and it has this ID, and you can see here in the return that's coming over, we've got the ID of the thing that we're interested in. So if we wanted to, let's say, when users are created, automatically fetch some entitlements from an external REST server and put them back into the product. Now we've got the user's ID, so we can do subsequent puts to push those entitlements to that system. And again, this is going to fire every time things are created, and we'll see how powerful the server is after I create 100 users. And we've got a bunch of fires over there. 100 new users, 100 posts over here. And so what I'm using in this example is a PowerShell library called Qlik CLI. Technically, it's Qlik CLI Windows, because there has been a release for the cloud version of Qlik that's taken over that name. It's just a wrapper for things. You can do this all in raw PowerShell if you want. I just find Qlik CLI to be a very convenient shorthand for having to handle certain things. I don't need to define what I'm doing. I can just pass a param and it'll do what I need to. For example, invoke Qlik post. You can do post using either C# or native PowerShell libraries or commandlets. This just makes it easy. So we've gone over notifications. Again, extremely powerful thing that's too underutilized. The other one is a external program task. So an external program task is a type of task inside of the Qlik product. It can be chained like any other task. It can be triggered based on a schedule like any other task, and it can call something. It can call a script, let's say. So in this example, we'll go ahead and let's just make sure that I've cleaned up after doing some validation this morning. Yep, we're all good there. We've created an external program task. We're calling PowerShell, and we're calling a script that's located in some directory. And we've given the task a name. We've not done any actual scheduling or setting up triggers. This is just a basic example. And this actual PowerShell file, again, relatively basic. It's just opening and creating some random files in this directory. It's set to create those 5 files, but again, from Qlik, we are now doing something well outside of Qlik, which the common use case for this is going to be things like doing something before an application, and then application reloads, and then consuming that output inside of an app. So the telemetry project, which my team owns and created, we call some Node.js scripts to fetch metadata about applications, a list of apps, a list of sheets, and which apps are located, and a list of visualizations there and their types and which apps they're located in. And that is chained to a Qlik app that is reloaded. So that's one flow, right? We're doing something before an app to be consumed inside of an app. The alternative way, right, is that we reload the app first. So we just do a reload, and then let's say we cache warm the application. So we kick off a cache warm process to open that application up programmatically so that it's always in memory post reload. Again, these are just 2 examples, but these are 2 examples where the inputs from Qlik can interact with things outside of Qlik, and they interact in a logical manner, right? You shouldn't be using Qlik as your enterprise scheduling tool that's running your automation jobs for all of your environment. But if there are things outside of Qlik that Qlik depends on, you can logically tie those 2 together, and you don't have to worry about coordinating necessarily outside of Qlik if you don't have an enterprise scheduler to handle those tasks. So again, and I'll post this PowerPoint, but these are the example bodies of things that we're doing, right? We're just sending in double quotes some listener, and it's going there. We're sending a path to an exe, to an executable, and we're sending some potential parameters. In this particular example, this is the way to tell us to bypass the execution policy for PowerShell scripts, and it's giving us the location escaped because this is JSON to some script. Again, you can do this to Node, Python, whatever programming language. Batch files if you so desire. Some quick tips and tricks. These are the sort of common things that break when trying to do automation endpoints or automation inside of the product. Updates, you typically will do a get. Do whatever you want to change, like change the name of something, and you want to modify the modified date pretty commonly, and then do a put, right? So you're replacing, but you're signaling to the repository that this change set is newer than the one that it currently has. Access inside of Qlik is fed down from security rules, and those security rules do have a context. Hub, QMC, or both. By default, when you make a repository call, you're accessing it using the context of management access. So if you get a list of apps, like a root admin would see all applications, in the QMC that is, in the hub they may not have elevated access. But you can pass an additional header to define that I want to access via the hub. So let's say you wanted to build an auditing application. You'd want to specifically say, when users access it through the hub, what do they see? You may want to do the QMC as well, but the most common use case here is viewing what people can see in the hub. It is strongly encouraged for you to do consistency checks inside of your script, right? If you're trying to change something and you want to make sure that you're changing just one thing, you can't take the record from an app that's named App1 and put it into another app that happens to be named App1, right? That will fail, right? So you typically will want to do some filter. You will say, name equals foo, app.stream the apps in a stream, and then you want to check a count. You want to make sure you're only getting one entity, because otherwise the subsequent fail to get the full record for that entity or to do subsequent puts, those are going to fail. To be honest, when you're writing automation scripts, consistency checks are the bulk of the work that you do. Some helper libraries. This is really encouraged if you don't have experience writing sort of raw RESTful calls, but they're helper libraries in a variety of formats. I picked 3 that are most common, that I see most often, but I can guarantee there are a litany of others. QRS Interact, made by a team member of mine inside of Node, puts a wrapper for Node. QS API for Python is rather helpful, and then Qlik CLI for Windows. You don't have to use them. You can use them in whatever programming or scripting language you so desire, but these are accelerators in many respects. So that's the sort of brief overview. Let's open it up for questions, because I know we ran long before, and while that's happening, let me go ahead and pull up the chat. So there's a question about, do notifications have a retry or error mechanism? If the QRS goes down, the subscriptions are all lost, right? They're intended to be ephemeral. So if you're relying on these, you're going to have to recreate these. In a project I linked to here, there. Let's see how Dan explains it. But we can see here he's got a variety of modules. I mean, one's for the console, but you can see here we've got basically 2 key ones, right? We've got a notification creator, which regularly creates things. I don't recall his frequency of doing things, but I thought it was every 30 seconds. But he's just repeatedly creating a notification, 60 seconds. It's just repeatedly creating a notification, because again, you get the same handle back. You're not going to get duplicate responses. And then we've got a listener that's actually listening for things, and then it's going to be doing the actual work unless he's externalized that somewhere. But yeah, this is a particular project that I know at least one customer is using this in a somewhat of a production scenario. But it basically listens for application changes and then pushes them to external systems. And this actually has a workflow component that's built into the product using custom properties. So you can have users optionally promote things to other tiers. You either promote them, and this includes an email alert, promotes them to be approved, or ask for promotion to sort of app admins or stream admins that can then optionally approve things, and then it'll send an email saying it has been approved or denied. Again, this is all an example project. While someone is running this in production, I certainly wouldn't encourage it, but it's a great example of the concept. And we had a question or comment about the QMC looking tuned. This is the example of the default view of the QMC inside of June 2020, which is, I wouldn't have designed it this way, but I think it's intended to be more performant. But it definitely looks a little bit different than what you may be traditionally used to.
Okay.
Any other questions? No, it's not broken. It's intentionally that way. Sort of what it's trying to do.
Is there any other questions, guys?
Yeah, if we want to sort of go over an example of something I wrote for a customer to, you can see here I'm doing a lot of, if else, or I could convert this to try catch, to try to basically do consistency checks for things. But the actual work of the script, I mean, it's probably 25, 30 lines, but the rest of it is all consistency. So, I mean, this is the style of things that need to happen when you're doing, full automation is just make sure you have those consistency checks inside of the scripts.
If I'm not mistaken, Qlik just released 1 week or 2 weeks ago, something like that, the admin playbook. Is this the kind of stuff that we will basically be seeing there? Like to run these scripts to help us to do this kind of stuff in terms of automatizing some of the stuff that we need to do on the QMC, or is it completely different topic?
They're related. So the admin playbook actually was created by my team in the Americas, and we do have things that can use Qlik CLI. We try to be cautious about doing that. We don't want to release code that does too much in the way of removing stuff that I think I wasn't the primary author of some of these pages, but we try to call it out and make it very clear, right? Please remove things manually unless you know exactly what you're doing, right? You don't want to be the DevOps person who pushes to prod, something that nukes the entire site because you want to automate the removal of things. But yeah, no, there are examples here, and we're certainly interested in expanding this down the road to have more automation available, whether it's using Qlik CLI or things like Qlik alerting to have examples of ways to automate the maintenance of a site.
Okay. You also mentioned the part in terms of the Qlik cache warm-up. Do we have already any script available for that?
So for cache warming, and I actually wrote this page, and it's best described as a tome because we go over a variety of approaches. So I basically cover three different tooling options to use. Cache Initializer is a tool that my team has taken over ownership from a former product manager at Qlik, and Butler, that's from Goran, who's on branch Slack, and then the Qlik scalability tool is also from Qlik and could be used for cache warming. But there are pros and cons of each approach, right? The Cache Initializer is relatively, I wouldn't call it stupid, but it's very basic in terms of its capabilities, but it's very easy to implement. So yes, there are examples here, and I'll dig up an example. I believe we posted this onto the architecture blog. There's a space in community where we tend to dump a lot of stuff about chaining these. So covering that exact scenario, you want to do a reload and then call an external program task, and the exact example I'm coming up with is preloading because that's the most obvious one. So I'll pass those along.
Okay, cool. Thank you. Yeah, really good, really good, really good. Guys, is there anything else that you guys would like to ask to Levi or? No.
Okay. Well, I'll let people go a little bit early, but as Steven said, I likewise monitor in branch Slack. So if you have questions, do reach out and let us know. Go to Qlik community as well. So just let us know.
Yeah, Levi, again, thank you very much for your time. I would like also to say that we will be sharing this video also very soon on our YouTube channel, so for people to see in the future. So, but again, thank you very much for your time, and yeah, all the best for you and for everyone that had the time to join us.
Absolutely.
Thank you very much, guys. Take care. Have a nice evening.
Thank you.